Article 210.4 of the National Electrical Code addresses multi-wire branch circuits. Specifically, it mandates that circuits supplying 15 and 20 amp receptacles in dwelling units must be supplied by a single circuit breaker or fuse. The main reason for this requirement is to prevent a situation where a single fault could cause a loss of power to multiple receptacle outlets, potentially creating a safety hazard. In the context of a hotel, guest rooms are classified as dwelling units under the NEC. If each hotel room is fed by a single number 8 MC cable supplying multiple receptacle outlets, each room needs to be supplied by a single 15 or 20 amp circuit breaker. It's important to note that the physical arrangement of the circuits, such as whether they share a yoke or strap, does not affect this requirement. Article 210.4 applies universally to all circuits that supply receptacle outlets in dwelling units regardless of their configuration. Approaching an electrical contractor with these concerns is a good step, as they should be able to offer solutions that comply with the NEC regulations. Also relevant is Article 210.11 Cone, which stipulates that guest rooms in hotels and motels should have a minimum of 2 separate branch circuits. This ensures continuous power availability even if one circuit experiences a fault. To elaborate on Article 210.4, it's crucial to understand the implications of using multi-wire branch circuits. A multi-wire branch circuit consists of 2 or more ungrounded conductors with a shared neutral conductor operating from a single phase of a 3-phase system, or from different phases of a single-phase or 3-phase system. When properly configured, multi-wire branch circuits can reduce the number of conductors required, saving on materials and installation costs. However, they also present potential risks if not implemented correctly. The key concern addressed by Article 210.4 is the possibility of overloading the neutral conductor. In a properly balanced multi-wire branch circuit, the current in the neutral conductor is theoretically zero, as the currents from the different ungrounded conductors cancel each other out. However, if one of the ungrounded conductors experiences a fault, or if the loads on the different conductors are significantly unbalanced, the neutral conductor can become overloaded. This can lead to overheating and potentially a fire hazard. By requiring a single circuit breaker for circuits supplying receptacle outlets in dwelling units, Article 210.4 ensures that all the ungrounded conductors associated with a multi-wire branch circuit are disconnected simultaneously in the event of a fault or overload. This prevents the neutral conductor from becoming overloaded and reduces the risk of fire. Moreover, the NEC contains specific requirements for identifying and terminating multi-wire branch circuits. These requirements are intended to ensure that electricians can easily identify the different conductors associated with a multi-wire branch circuit and that they are properly terminated. In addition to Article 210.4 and Article 210.11 Cone, other NEC articles are relevant to the installation of electrical systems in hotels and motels. Firstly, Article 210.8 covers ground fault circuit interrupter protection for personnel. This article requires ground fault circuit interrupter protection for receptacle outlets located in bathrooms, kitchens, and other areas where there is a high risk of electric shock. Secondly, Article 210.12 addresses arc fault circuit interrupter protection. This article requires arc fault circuit interrupter protection for branch circuits that supply dwelling units, including guest rooms in hotels and motels. Arc fault circuit interrupters are designed to detect and interrupt electrical arcs, which can be a common cause of electrical fires. Thirdly, Article 220 provides requirements for calculating branch circuit, feeder, and service loads. This article is important for ensuring that the electrical system is adequately sized to handle the expected load. It includes specific requirements for calculating the load of lighting, receptacles, and other equipment. Fourthly, Article 250 covers grounding and bonding. This article provides requirements for grounding and bonding the electrical system to ensure that it is properly grounded and that there is a low impedance path for fault current to flow back to the source. Proper grounding and bonding are essential for preventing electric shock and minimizing the risk of fire. Fifthly, Article 300 contains general requirements for wiring methods. This article covers topics such as the use of approved wiring methods, the protection of conductors from physical damage, and the proper support of cables and raceways. Sixthly, Article 310 addresses conductors for general wiring. This article provides requirements for the size, type, and installation of conductors. It includes specific requirements for the ampacity of conductors, which is the maximum current that a conductor can carry safely without overheating. Seventhly, Article 314 covers outlet boxes, device boxes, pull boxes, and junction boxes. This article provides requirements for the installation of these boxes, including requirements for the size of the box, the support of the box, and the protection of conductors entering the box. Eighthly, Article 400 addresses flexible cords and cables. This article provides requirements for the use of flexible cords and cables, including requirements for the type of cord or cable, the ampacity of the cord or cable, and the protection of the cord or cable from physical damage. Ninthly, Article 404 covers switches. This article provides requirements for the installation of switches, including requirements for the type of switch, the location of the switch, and the wiring of the switch. Tenthly, Article 406 addresses receptacles, cord connectors, and attachment plugs. This article provides requirements for the installation of these devices, including requirements for the type of device, the location of the device, and the wiring of the device. 11thly, Article 408 covers switchboards and panel boards. This article provides requirements for the installation of switchboards and panel boards, including requirements for the location of the equipment, the wiring of the equipment, and the protection of the equipment from overcurrent. 12thly, Article 518 addresses places of assembly. This article provides requirements for the electrical installation in places of assembly, such as theaters, auditoriums, and churches. These requirements are intended to ensure the safety of occupants in these buildings. 13thly, Article 520 covers theaters, audience areas of motion picture and television studios, and similar locations. This article provides requirements for the electrical installation in these types of facilities, including requirements for lighting, sound systems, and stage equipment. 14thly, Article 550 addresses mobile homes, manufactured homes, and mobile home parks. This article provides requirements for the electrical installation in these types of structures, including requirements for the service entrance, the wiring system, and the grounding system. 15thly, Article 600 covers electric signs and outline lighting. This article provides requirements for the electrical installation of electric signs and outline lighting, including requirements for the wiring, the overcurrent protection, and the grounding. 16thly, Article 620 addresses elevators, dumbwaiters, escalators, moving walks, wheelchair lifts, and stairway chair lifts. This article provides requirements for the electrical installation of these types of equipment, including requirements for the wiring, the overcurrent protection, and the grounding. 17thly, Article 680 covers swimming pools, fountains, and similar installations. This article provides requirements for the electrical installation of these types of facilities, including requirements for the bonding, the grounding, and the ground fault circuit interrupter protection. 18thly, Article 700 addresses emergency systems. This article provides requirements for the installation of emergency systems, including requirements for the power source, the wiring, and the overcurrent protection. 19thly, Article 701 covers legally required standby systems. This article provides requirements for the installation of legally required standby systems, including requirements for the power source, the wiring, and the overcurrent protection. 20thly, Article 702 addresses optional standby systems. This article provides requirements for the installation of optional standby systems, including requirements for the power source, the wiring, and the overcurrent protection. 21st, Article 705 covers interconnected electric power production sources. This article provides requirements for the interconnection of electric power production sources, such as solar photovoltaic systems and wind turbines, with the electric utility grid. 22nd, Article 725 addresses Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. This article provides requirements for the installation of these types of circuits, including requirements for the wiring, the overcurrent protection, and the separation from other circuits. 23rd, Article 760 covers fire alarm systems. This article provides requirements for the installation of fire alarm systems, including requirements for the wiring, the overcurrent protection, and the supervision of the system. By adhering to these NEC articles and consulting with qualified electrical contractors, you can ensure that the electrical systems in your hotel are safe, reliable, and compliant with all applicable codes and standards. In addition to the NEC articles already mentioned, it is also important to consider the requirements of the local building codes and regulations. These codes may impose additional requirements that are not covered by the NEC. For example, some local codes may require that all electrical work be inspected by a qualified electrical inspector. Other codes may require that certain types of electrical equipment be listed by a recognized testing laboratory. It is also important to consider the specific needs of the hotel when designing and installing the electrical system. For example, the hotel may need to provide power for a variety of different types of equipment, such as lighting, appliances, and computers. The electrical system must be designed to handle the expected load and to provide adequate power quality. In addition, the hotel may need to consider the needs of guests with disabilities. For example, the hotel may need to provide accessible outlets and switches. The electrical system must be designed to meet the requirements of the Americans with Disabilities Act. The selection of appropriate wiring methods is crucial for ensuring the safety and reliability of electrical installations in hotels. Metal-clad cable, commonly known as MC cable, is a popular choice for many applications due to its durability and ease of installation. However, it is important to ensure that the correct type and size of MC cable are used for the specific application. The ampacity of the conductors within the MC cable must be sufficient to handle the expected load, and the cable must be properly supported and protected from physical damage. Other wiring methods that may be used in hotels include electrical metallic tubing, electrical non-metallic tubing, and rigid metal conduit. The choice of wiring method will depend on the specific application, the environmental conditions, and the local building codes. Proper grounding and bonding are essential for preventing electric shock and minimizing the risk of fire. The grounding system must be designed to provide a lower impedance path for fault current to flow back to the source. This will help to trip the circuit breaker or fuse in the event of a fault, preventing a dangerous buildup of voltage. The bonding system must be designed to connect all metal parts of the electrical system together, creating an equipotential plane. This will help to prevent voltage differences between different metal parts, reducing the risk of electric shock. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the electrical system from overloads and short circuits. These devices must be properly sized and installed to ensure that they will trip in the event of a fault, preventing damage to the electrical system and minimizing the risk of fire. The selection of appropriate lighting fixtures and controls is important for both energy efficiency and guest comfort. LED lighting is a popular choice for hotels due to its high efficiency, long lifespan, and low maintenance requirements. Lighting controls, such as occupancy sensors and dimmers, can help to reduce energy consumption and improve guest comfort. Regular inspection and maintenance of the electrical system are essential for ensuring its continued safety and reliability. Inspections should be performed by a qualified electrical inspector and should include a thorough examination of all components of the electrical system. Maintenance should be performed by a qualified electrician and should include tasks such as tightening connections, replacing worn or damaged components, and testing overcurrent protection devices. In conclusion, ensuring compliance with the NEC and local building codes is paramount for the safety and functionality of hotel electrical systems. By paying close attention to the requirements for multi-wire branch circuits, grounding, bonding, overcurrent protection, and other critical aspects of the electrical system, you can help to protect guests and staff from electrical hazards and ensure the reliable operation of the hotel. Remember to consult with qualified electrical professionals to ensure that all work is performed in accordance with applicable codes and standards.